When we want to find the local or absolute maximum and minimum values of a function, we want to find its derivative. So we're going to take the derivative of this function, and since this is a polynomial function, we're just going to have to use the power rule. So we have 3 times 7 is 21, x to the 1 less than 3, which is 2, minus 2 times 8 is 16, x to the 1 less than 1, which is 1, then minus the derivative of negative 16x is negative 16. The derivative of 15 is 0. So what we're going to do is we're going to figure out where this derivative equals 0 or does not exist. Well, there's no denominator here, so we don't have to worry about does not exist. So we just want to figure out where this derivative equals 0. So we're going to have to factor this. And this factors into 7x plus 4 times 3x minus 4. Whatever way you have of working out factoring, that's what you need to do, is get your two factors. So then you say the first factor equals 0 because you want this equal to 0, or the second factor equals 0. So we end up with 7x equals negative 4, or x equals negative 4/7. On this side we have 3x equals 4, or x equals 4/3. So these are our two critical values, or critical points in the problem. We're going to make a number line, and on this number line we put negative 4/7 and 4/3 relative to each other in correct position. And we're going to test the derivative as to whether the derivative is positive or negative on any one of these intervals. And that will tell us if our function is increasing or decreasing, and that will give us our maxes and our mins. So if we pick a number, let's say 0. 0 is a nice number to pick in this particular interval in the middle. So if we put 0 back into the factored form of our derivative, we have, if x is 0, we're going to get a positive in the first factor, and we're going to get a negative in the second factor. A positive times a negative is a negative. We don't actually care what the value is. We just care if the function has a derivative, which is positive or negative. So let's test a great big huge number like, I don't know, 100, let's say. If we put 100 into the first factor, we obviously get a positive. And if we put 100 into the second factor, we obviously get a positive. So a positive times a positive is a positive. Now let's test a negative number like negative 100. We get a negative in the first factor. We get a negative in the second factor. So a negative times a negative is a positive. Now why is that important? Because we know that if the first derivative is positive, our function is increasing. And if it's negative, our function is decreasing. So what we have here are the intervals over which our function is increasing and decreasing. But moreover, if a function is increasing and then decreasing, this gives us a max at this point. And if the function is decreasing and then increasing, this gives us a min at this point. Now, we have to think about this in terms of, are these relative maxes relative mins or absolutes? Well, this function has no endpoints, so it's increasing before it gets here. It's decreasing afterwards. It hits bottom here and it goes up. Well, if you notice, this goes up forever on the right and goes down forever on the left. So these maxes and mins can only be relative. They can't be absolutes. They have to be relative or locals, as this problem states. So we have a local max at x equals negative 4/7. So if we look here, local max, x equals negative 4/7. Local min at x equals 4/3. So this would be answer D. Now it's not absolute because this function keeps going up forever on the end, increasing, and down forever on this end. So these are called local or relative maxes and mins.